In this video, we explore Euclid's 2,000-year-old proof that there are infinitely many primes, a timeless and elegant mathematical gem. Let's assume that there are only a finite number of primes. Let's call them P1, P2, through to Pn. Now let's construct a new number, n. Multiply P1, P2 through to Pn, and then add 1 to the result. What can be said about this new number, n? There are two possibilities. Case 1, n is prime. In this case, we have found a brand new prime that isn't on our list. Case 2, n is composite. None of the primes P1 through to Pn can divide n, because that would leave a remainder of 1. So, n must have a prime factor apart from those already listed. In both cases, we found a prime that's outside our original list. That's a contradiction. This elegant proof shows that no matter how far we go, there will always be more primes waiting to be discovered.